Hey students, greetings of the day. This is your Any Rao, Faculty in Physics Cum Director VIP classes. So would like to bring today laws of motion and friction part 3, okay, for discussion. See, all these questions I am framing and keeping point of view competitive examinations. Okay, so now we are going to discuss about laws of motion friction 3. Already we have done laws of motion and friction, so behind formulas one series video. Okay, we can go through it, complete basics are there, and also I explained about friction in that particular video. Okay, now coming for now these numericals based on this, so just I will revise 2 minutes regarding the friction. Already we know friction is the one what happens which opposes the relative motion of an object, okay, with respect to another surface, you can say. Now one body actually moves over the surface of the other, so the relative motion, okay, is being opposed by a particular tangential force, which we are calling as what, which we are calling as friction. Now we have already discussed about 3 types of frictions. One is called static friction, kinetic friction, or rolling friction we have seen your level. Okay, now and also we have seen friction proportional to what, frictional proportional to normal reaction we have seen, and from this we have seen F is equal to mu into N. So where mu is called coefficient of friction and N is called normal reaction. And also we have also said that friction depends only on normal reaction. It also depends on nature of surfaces in contact. Okay, this keep in mind. And for 3 types of friction we defined 3 kinds of coefficient of friction. One is called static, another is called kinetic, another is called what, rolling. So up to your lower classes, or else we only talk about these 2 only. Fine. And also we have seen that static friction value is more than what, kinetic friction is more than what, a rolling friction. So these points also we have seen as a part of revision. You're getting right. Now let us do one by one. So in laws of motion we spoke about Newton's first law, Newton's second law, Newton's third law, momentum, and calculations. Now by using all these formulas and formula of the friction, F is equal to mu into N, friction depends on nature of surfaces in contact, or it also depends on what, normal reaction. Friction doesn't depend on what, area of contact. Okay, so that point already we have seen. Now coming for this numericals, let us see one by one now. Before series laws of motion friction 2, 10 numericals I have solved. Let us solve few more numericals over here. Now see the question. The system of bodies are placed as shown, okay, on a smooth horizontal surface. Pulleys are frictionless and strings are inextensible. Okay, take value of G as 10. He's asking the net force acting on 2 kg block is 50 Newton, he's saying. Okay, now you see, draw the FBD. What is FBD? Diagrammatic representation of all the forces acting on the body we are calling as FBD. So if you consider 5 kg, the force acting on 5 kg is 50 Newton downward, and say this, in this case tension is T1. Okay, so here also tension is T1. So in a given string, tension remains the same. Now this side, for example, tension you can call as T2. So here also what happened for this block, tension always acts away. I mentioned already. Okay, in laws of motion you can see this is T2. Now for this 1 kg block, away means above. For this 2 kg block, away means left side, T2. Okay, after this, now already we have seen that acceleration formula is F net pulling force by total mass of the system. Now coming for net pulling force, so this side pulling force 50 Newton, this side pulling force M into Z, 1 into 10, that is 10 Newton. So net pulling force, right side is this one, so opposing its motion, left side is this one. Okay, so net will be how much now? 50 Newton minus 10 Newton by total mass. Here 1 plus 2, 3, 3 plus 5. 3 plus 5 how much? That is 8 kg. This will be 40 Newton divided by 8. How much, students? This will be 5 meter per second square is net acceleration. Now the first option is saying net force acting on 2 kg block. Always we have seen from Newton's second law of motion, F net is always mass into acceleration. Yes or no? So on 2 kg, so net force on 2 kg will be, mass will be 2 kg and acceleration will be 5. So this will be how much? That is 10 Newton. So net force on 2 kg block will be 10 Newton, but he is saying 50. So this answer will be wrong. Now coming for, see why we have taken total mass means because of this net force of 40, total entire system of blocks are moving. That's why we took total mass as 8 here. You're getting? Now acceleration produced in 2 kg block. So acceleration produced in 2 kg block is 25 meter per second. See, strings are inextensible. When the entire system is moving rightward, so this will be going downward, this will be going upward, this will be going rightward. Strings are inextensible, so they will have the same acceleration. Okay, so not different. So this answer also wrong. Is asking choose the fine. So find strings are inextensible. The just options are given. Okay, acceleration of 1 kg block is opposite to acceleration of 5 kg block. Obviously true it is. Yes or no? No. That is true. This is 5 kg going down, 1 kg again. So both A and B. That means the question here something is when cutting has gone. Choose the incorrect statement will be. So incorrect. If you consider choose the incorrect statement. Incorrect statement. Incorrect statement means answer both A and B will be incorrect. So you can mark a D option. So something here when I am cutting, no, it has gone here. Yeah. Now next you can see here you see Fs, Fk and Fr represent static friction, kinetic friction and rolling friction, and which of the following is correct option? Just now I have mentioned already during division. So static is more. Why? Because to start the motion we have to overcome large amount of friction. Why? Because more interlocking here. Okay, when surfaces are there, you can imagine, for example, any surface, if you consider this surface and a block is staying over here. If you see irregularity present over here also, on this surface also. Okay, so these irregularity interlock. So when you are applying force to move, no, these interlocking is like what they rupture against each other. So we have to overcome large amount of static friction. So static friction is more. Once the body starts moving, no, then what happens? Only opposing force is what? So what happens? Interlocking will not be that effective once the body is moving. Already some irregularities were ruptured. So to maintain the motion, that much amount of force is not required than to start the motion. So therefore, kinetic friction is smaller than static. Now rolling friction is what? So very easy, you can say when a body rolls, slides, if you compare the time, no, rolling is very fast, it goes, no, that means it takes lesser time. So Fs is more than Fk, Fk is more than what? Fr. So you can have relation, static is more than kinetic, kinetic is more than what? Rolling. So this should be our option. Okay, right, student. Now next is saying about regarding friction, which of the following frictional force is self-adjustable? So in the theory of laws of motion and friction, I mentioned you, as you are applying the force on a particular body, if the body at rest, frictional force is 0, I said. If you apply some amount of force here, student, okay, if you apply some amount of force, what happens here? For example, 5 Newton applying. So again, if the body is not moving, say acceleration 0, okay, or not moving, velocity also 0. So then opposing force will be 5 Newton. If I increase the force to 6 Newton, still there is no motion. For example, then friction also 6. Like this, with respect to applied force, the value of friction also adjusts. And this friction is coming into picture when a body is about to move. This kind of friction is called what friction? Static friction. So static friction is what kind of friction? Self-adjustable friction. Therefore, which of the following frictional force is self-adjustable means a static friction. Clear? Right. Now coming for, now you can see here applied force in adjacent figure just tends to change. Okay, applied force in adjacent figure just tends to change the position of the body. The magnitude of maximum limiting friction just tends to change the position but not yet changed. I mean about to move. Then the maximum value of static friction which comes into picture is called limiting friction. Okay, and the value is how much here? Now nothing but in this case still the acceleration is not produced. That means opposing force must be equal to applied force. Therefore, in this case, friction becomes how much, student? 150 Newton. This is the right answer. Okay, frictional force always what it does. Okay, very important point. So opposes the motion of bodies, opposes the relative motion of bodies, acts in the direction of motion of bodies. Both A and B is saying. Okay, so both A and B. So already we have discussed the definition of friction. Friction opposes relative motion of body. Opposes the friction always opposes the motion? No, sometimes it supports also. How do you understand it supports? So for example, I have this remote, okay, in my hand. When I'm moving my hand forward, okay, or side by, if like this, if I like this, okay, along with my hand also, this what object also moving along with my hand, isn't it? So if I have a surface or any hand like this, if I'm moving the surface forward, so this block also tries to move forward, okay, is moving forward. So its tendency of skidding is backward, but tendency of skidding is backward with respect to surface means friction opposes tendency of skidding. That means friction on this object will be forward. Now can you tell me, when I am moving the surface rightward, okay, what happening? Object also moving rightward. So if you observe, an object cannot move unless a force is acting. So what force is responsible for its motion? Obviously friction. There is no other force in that horizontal direction. Therefore friction is supporting here motion. So you can also say, but it opposes tendency of skidding, of course. So most relevant of what? Friction of force always opposes the motion of bodies is, okay, you can oppose the relative motion, just obviously. What happened? Tendency of skidding is backward, so friction is acting forward. But it is helpful for motion, no? Helpful for motion. So opposes relative motion is correct, and opposes the motion of bodies may not be always true. Okay, it may also support the motion. Now in this case, supporting, no. So in this case, so in that sense, you can say both A and B. Okay, so more relevant answer is opposes relative motion of bodies. Fine. Now, frictional force depends on what parameter? Frictional force depends. Friction depends on nature of surfaces in contact. That is true. So area of contact, no, it depends only on normal reaction. Okay, so if you consider, for example, you can take an object like this kind of object. So move and make the object to lie on a surface. Dimensions are changed here. Area of contact is changed here. Okay, so here you can say large amount of area of contact is in contact. Okay, if you make the same object, okay, so this area is larger than this area, but here pressing force is mg, so normal reaction is upward. So here also pressing force is mg, normal reaction is upward. Normal reaction not changing, but you can say what area of contact is different here. So as you know, if you are try to apply a force and when try to move it, no, what happens here when you try to move it? So something is opposite, opposing force is called, what you have seen, friction. But we have seen all the laws of friction. Friction depends only on what? Normal reaction, independent of area of contact. So but in case of fluids, it depends on area of contact. Okay, yeah, that viscous drag we call. Normal force between contact surfaces and body, yeah, this is true. Both A and C, these two answers are right. Okay, friction depends on what you can call normal reaction and depends on what? Nature of surfaces in contact, right? Now in this question you see a force of x Newton opposes the motion of body and surface as shown. So for example, some force x Newton is opposing, that may be friction. Okay, find the magnitude of x from the following diagrammatic representation. So here net force formula is what? Mass into acceleration. So how much bit of force acting here? So net force means one force rightward, another force opposing leftward. So resultant vector sum will be rightward force minus leftward force. So what you can write? 75 Newton minus x Newton. Okay, this must be mass is 5 kg. Acceleration is mentioned as 2. So 75 minus x is equal to 10, students. So x will be 75 minus 10 Newton, which will be how much? That will be 65 Newton is the answer. Okay, yeah. Now see this question. A block of mass 1 kg is what? Pulled by another block of mass 3 kg on a surface. The surface offers a frictional force. Here frictional force is given directly. So 0.5 kilogram weight. All of you know very well. So 1 kilogram weight value, how much? This is the weight of body of mass 1 kg. Yes or no? The weight of body of mass 1 kg. So weight of body of mass 1 kg is m into g. So mass is 1 kg into g is how much? 9.8. So you can take here. Now approximately for calculation, for example, if I give in the bracket, say take g 10 meter per second square for calculation purpose. So 0.5 kilogram weight means 0.5 into 1 kilogram weight is, you can write down, 1 kilogram weight is weight of body of mass 1 kg. So 1 kg into g. 1 kg into g 9.8, but I gave here 10, so 10, that becomes so 10 Newton, or else you should write 9.8 Newton, exact value. So 0.5 into, if I take approximately 10 Newton, how much better is it? This will be 5 Newton. Okay, so frictional force how much here? 5 Newton. Now if you see here, 1 kg block lying, 3 kg blocks here. So 3 kg surface, one block 1 kg is pulled by another block of 3 kg. If the surface offers frictional force, 1 kg block acceleration produces. So here there is no contact here. Okay, yeah, this will be how much better? You can write down 3 kg weight is 30 Newton, and so tension some value. Tension will be here acting, no, internal force. So if you consider these two bodies together as a system, this tension becomes internal force. Internal force do not cause motion in a body. Okay, for example, you are sitting in a car, or if you are sitting in a chair yourself, okay, in a bench, you try to push yourself. So will the bench is moving? No. Why? You are applying force. No, you are part of a bench. So you plus bench, if you take together as a system, when you push the bench forward, your back is pushing the bench backward. So the same hands on the same bench, one force is forward, equal and opposite reaction is backward. They get cancelled. Net force is equal to 0. Therefore, internal forces do not cause motion in a body. So here friction, For this 1 kg and 3 kg, tension becomes internal force. Okay, only external forces you consider. So here external force means 30 Newton, and here frictional force, how much we just found? That is 5 Newton. So net pulling force, how much better now? Acceleration is equal to net pulling force by mass, 30 Newton downward and 5 Newton is opposing. 5 Newton total mass. How many masses are moving because of this force? Because of this force, how many masses are moving? That is 1 plus 3. How much, right? That is 4 kg. This becomes how much? Now 25 by 4 meter per second square. Okay, so now he's asking on 1 kg acceleration produced if the surface friction is this acceleration of system. Acceleration of system means acceleration of 3 kg or acceleration of 1 kg. Why? You are in a bus accelerate at the rate of 1 meter per second square. Will both of you have same acceleration or different acceleration? It will be same. Why? If you have different acceleration and bus has different acceleration, no, so both of you will have relative acceleration, means you will move with respect to bus will move with respect to you, but you are moving together, no, relative acceleration is here 0. So we can say both the bodies are having same acceleration. Okay, right. This is the answer. Next you will write two identical bodies are placed on a rough surface if mass of the body is 5 kg and if first body remains at rest and second body moves with 5 meter per second velocity, the ratio of frictional forces between them and surfaces of contact. Okay, let us draw the diagram. Two identical bodies are placed on rough surface. Fine, identical bodies are on a rough surface, no issue. Surfaces are rough here. Mu is not 0. Okay, two identical bodies are placed on rough surface if mass of the bodies is 5 kg, no issue, 5 kg. If first body remains at rest, not moving, velocity is 0. Second body moves with velocity of 5 meter per second. Okay, so bodies are identical, they are placed on rough surfaces, they may be different. Okay, yeah. Ratio of frictional force between them and surface of contact. See, this body is still not moving, but you're applying force. Oh, first body at rest. Okay, but he didn't mention that you're applying force, right? Two identical bodies are placed on rough surface. Your body 5 kg, and if the first body remains at rest, second body moves, but then the ratio of frictional forces between them and surface of contact. Okay, see here, he didn't mention that you're applying the force. If you are applying the force on this one still at rest, means friction definitely will act. Friction comes into picture. But he didn't mention about applying force, means you are not at all applying. Means how the body, according to Newton's first law, a body at rest will remain the same state of rest. A body moving with uniform velocity will continuously move with the same velocity. Yes or no? So it is at remains at rest. When it remains at rest, no question of friction. Friction is 0. Fine. Now coming for this body is moving with 5 meter per second. Moving with 5 meter per second constant velocity. No. So that means you are applying some force here. So opposing force also acting. But body constant velocity means what? Look at the board. When velocity is constant, acceleration beta 0. When acceleration is 0, F net is mass into acceleration also what? 0. Net force must be 0. Net force means already force is applied, no? So the equal and opposite force must oppose the motion. Then only it becomes net acceleration 0, velocity constant. So in this case, frictional force will be equal to how much? Applied force. Applied force. Okay? So frictional force will equal to applied. Some value will be, but ratio is asking. First one is 0. 0 by something is what? Is 0. Okay, so 0 is to 1 or 0 by some value. Clear? Yeah, that's the answer. You can say 0 is to 1, no, it may be any value depending on the applied force. Okay, 0 is to 1 is 0, so simply you can say. Yeah. Next, a vehicle of mass 100 kg moves with a constant speed of 72 km per hour. Okay, yeah, so speed of the vehicle is, you can write down 72 km per hour. So 72 into 5 by 18 beta, 8 4s, we will have 20 meter per second. Due to application of brakes, if it comes to rest in a distance of 50 meters, so you are having a bus or a car, doesn't matter. You are applying the brakes and it is coming to rest after some time. It is coming to rest. Due to application of brakes, it comes to rest within a distance of 50 meter. Okay, this distance also given, which is equal to 50 meter. When you are applying the force, okay, the magnitude of frictional force is dash kilonewton. It moves with constant speed 72 km per hour. Due to application of brakes, it comes to us in a distance of 50 meter. Okay, the magnitude of frictional force is, you can just find retardation how much here. So by third equation, what you can write, v square minus u square is equal to s. Hope you remember the equations, yes or no? So first equation is v is equal to u plus at if acceleration is constant, and next s will be how much, s will be ut plus half at square. And third equation we have seen v square, kinematics we have seen, you can see my kinematics one short revision video, okay, for understanding better. So if you know, it's okay. V square minus u square is equal to as. Now final velocity is 0, initial is 20 meter per second square. So 2 into a into s, displacement before coming to rest is 50 meters, student. So now a becomes minus 400 by this 250 is 100, no, this is 100, so will become minus 4 meter per second square. Can you tell me why minus here? Body retarding, velocity decreasing, so change in velocity is negative. Minus indicates retardation. Okay, yeah, retardation is equal to 4 meter per second square. Acceleration is equal to minus 4 meter per second square. Fine. Yeah, this is now this is because of what? Because of application of what? Frictional force. So retardation. So what is retarding force? Retarding force is mass into retardation. So mass value how much? 100 kg vehicle, 100 into retardation is 4 meter per second square. This is kg. So total becomes how much? 400 Newton. Kilonewton, that means kilo means by 1000, that is 0.4 kilonewton. Okay. What is, so this is based on equation of motion, uniform acceleration, and opposing force, net force formula concept. Okay. Next is, students, now two bodies made of different materials are moved on a surface which offer same frictional force. Okay, bodies made of different materials, they are on same surface. Okay, same frictional force, they offer same frictional force, no issue. ff, mass of the two bodies is, so mass of first body you can take as 20 kg. Okay, and mass of second body he is saying as 30 kg, students. So then the ratio of coefficient of frictions is, acha, yeah, two bodies of made of different materials are moved on a surface what, which offers same frictional force. Okay, frictional force is same, the mass of the two bodies are 20-30, then the ratio of coefficient of friction. Okay, no issue. As then horizontal surface, right? So you can take its weight mg will act downward, normal reaction say n1, its weight will act mg. If you want, you can calculate 30 into 10, that will be is equal to how much? 300 Newton. Normal reaction will be upward n2. Here weight will be 20 into 10, you can write down as 200 Newton. So frictional force, oh, normal reaction, but fine, pressing force is different based on nature of surfaces, friction may vary, but it is such a way that same frictional force. Fine. The ratio of the coefficient of friction, so now you can say F is equal mu into n, the same frictional force, no? So F1 is equal to F2, this is simply mu1 into n1, this is simply is equal mu2 into n2. Asking ratio of coefficient of friction, simply ratio of normal reactions, that is inverse ratio n2 by n1. Okay, so n2 will be balancing vertical direction, here 300, here 200. How much beta? That is 300 by 200. 2 get cancelled, 2 get cancelled, which answer is 3:2. Okay, so like this, for same frictional force, as nature of surface are different, so coefficient of friction is different, because so coefficient of friction depends on what? Nature of surfaces in contact. Okay, this is what you have done complete word. So few numericals based on what? Nature of friction, how what friction will does, friction opposite relate to motion, and then value formula, how to use F is equal mu into n, and net force formula F is equal m into a, and calculation when friction is opposing the motion, and all such kind of questions we have seen. Okay, this is what the just I made for your sake. Practice numericals. See, as I am go on uploading basic numericals, practice exercises after basic discussions, please go through them and solve once your practice increases. Okay, fine, student. So this is what we have done entire thing. This is laws of motion and friction series 3. Okay, practice of numericals. So hope you like my video, so please do subscribe and share among all your friends. Okay, if you have doubts and all, please post the doubts also, I will address your concerns. Okay, so thank you all. So be in touch and be tuned to VIP classes. Thank you all. Good day.